Question 2 is a proof question, and I'm looking here at a quadratic that I'm needing to show is greater than 0. So where that's the case, we're typically going to be completing the square. So in my margin here, I'm just going to complete the square for the expression that I've been given, which is going to be x minus 4 all squared minus 16 plus 17, which is x minus 4 all squared plus 1. Now that's going to help me to then create my proof statement. So for my proof statement, I'm then going to start from this idea of x minus 4 all squared would always be positive. So that's positive for all values of x that belong to the real numbers. Now, if that's true, it must follow that x minus 4 all squared plus 1 would be strictly greater than 0 for all values of x that belong to the real numbers. Now we've seen from my little margin working on the side that another way of us writing this down is to say that that's x squared minus 8x plus 16 plus 1, and that would be again for all values of x with x belonging to the real numbers, and that is obviously equivalent to the statement that we want to prove, which is x squared minus 8x plus 17 is always greater than 0 for all values of x belonging to the real numbers. That's my answer for part 1. For part 2 of this question, I'm given a worded setup. If I add 3 to the number and then square the sum, so I've got some number x and I'm adding 3 to it and then I'm squaring the sum, the result is always greater than the square of the original number, so x squared. And what I need to do is to state, giving reason, whether the statement above is always true, sometimes true, or never true. Well, now that I've transposed this from text into mathematics, we can then start to interrogate it a little bit more. So let's have a look at this now. What would I have on the left hand side? So expanding that, that's going to be, say, x squared plus 6x plus 9 is greater than x squared. Well, another way of stating that would be to say that 6x must be greater than minus 9, or x must be greater than minus 9 over 6, or we would write that down simplified as 3 over 2. So it would appear that this statement is true so long as x is greater than negative 3 over 2. Now we can show that if we take the value, let's say x is 0, then I'm going to have 0 plus 3 squared, which is 3 squared, and 3 squared is definitely greater than 0 squared, so yes, it's true in that case. However, if I pick an x value that's less than minus 3 over 2, so let's pick minus 2, if x takes the value minus 2, then I'm going to have minus 2 plus 3 squared, and I'm going to have minus 2 squared. Now, the left-hand side gives me 1, and the right-hand side gives me 4. And it's quite evident that 1 is not greater than 4, so that would not be true. So let's just go back to the statement of the question. State, giving reason, if the above statement is always true, sometimes true, or never true. Well, it's true in these cases and not true in these cases, so our final answer is to say sometimes true. And the condition that we've got is that x needs to be greater than minus 3 over 2 for this to be true.